Hi community. I'm Ziming Liu. I'm the second year PhD student of University of Sheffield, and my project is supervised by my Professor Xiaoli Chu, and also our project is supported by the Europe Horizon and EPSRC. So our presentation, we are going to start with 3 questions. So first is, what's the problem? Our research is really focused on the wireless communication, and before the signal tower transmit the signal outside, they are going to pass through 5 critical components, and our research is focused on the radio resource control component. And that component is to manage the mobility, the connection, the quality of service of your 5G work, and also the right side picture is showing the standard procedures of how the RFC control your phones. But the problem is, like, all of this control, the procedure is really fixed and based by rule, and it's not like fixed dynamic urban area or more complexity situation. So we now put a large language model or the AI agent to replace this area to make the 5G network automation. And the question is, like, where we get this data from? And we try to sync the data with simulator, but it's not work, it's not perfect, and the result is we do the road test. So basically, we self-driving a car around the London city, and we try from the sky, we take the cable car, and also we take the road around Thames River, and you can see there's 4 circles around the top. And you can check the right top. There is a field area in North London, and you can check this line was being broken. And the funny research, funny fact is that, like, when we driving around that road, there is a giant truck block our signal, and because that area is really quite empty, there's no reflection resources, so our signal is just totally blocked. And you can check the third circle. There is a dot around there. It's like, that means, like, we don't move anymore. It's like we taking the lift from down to the bottom. We just, like, take a lift around the Sky Garden. The interesting thing is, like, when we meet the security guard, like, they say, like, you visit the Sky Garden, but only take the lift. I say yes. And even more, like, we got this data, we got this raw data, and how we benchmark our agent. So we provide this architecture. So we give the agent, the principal idea is, like, we create agent at the real base station and then how they manage the role of the user equipment. We set the target for the base station. You have to manage it. You have to set up the connection. And for the role of the UE or the user equipment should be to execute this information. And how they execute this, they're using the function we provide by this large language model, and this function will get the real data from our real database. And that's still not. And I'm going to show, like, 2 examples here. So for the case study, the A3 event trigger, the A3 in our telecom means, like, handover. Because, like, if we got to base station or the cell network, we always got some, like, overlap to help phone to transfer from the cell 1 to the cell 2. And for this A3, it means, like, the signal is going to be weak and need to be transferred to another base station. And like, the user equipment are going to say, our signal strength is very weak, I need to do something. And the base station receives this message, I will help you configure. So you make a measurement first, and then you will call this function, get the measurement function, and get the real data from the database, and then execute the exchange base station action, and then get the result. And from case study 2, is the carrier aggregation and discontinue reception optimization. And that means, like, your phone will, like, this is not, like, awake any time. It's just, like, sometimes going to sleep. And then if the sleep window didn't match the base station, they will lose a lot of throughput, and they'll execute that. And because, like, our data is not perfect, it's still on London. I want to contribute to this UK Oman community, and to, like, as an example, we're going to publish the method to collect this data and help everybody joining us and to make this data set as big as they can. And and also I think this data is not benefit for us, also benefit, like, the Professor Liu's speak. Yes, because we also consider about the GPS trajectories. And thanks all. That's my speak.